I am Dr. W. Donole from Kamla Nehru Mahavidyalaya, Nagpur. Today we are discussing the defects or imperfection in the crystalline substances. The crystalline substances which occur in the nature do not have perfect crystalline structure. Such solid or such crystalline solid have defects due to disorder or irregularity in the arrangement of the particles, and these irregularities is also known as the defects or imperfection. And it is observed that these defects or imperfection are created during the process of crystallization, and defects are more when the rate of crystallization is higher or faster rate, and it can be minimized by carrying out the process of crystallization at slower rate. And actually these defects are different in different crystalline solids, and it is observed that there are mainly three types of defects. One is point defects, line defects, and the plane defects. So all these defects, stoichiometric and non-stoichiometric defects, we are discussing in this part. So today's topic is the solid state and part number 9, and in this part we are discussing different types of defect. What is crystal defect, that is imperfection, point defects, stoichiometric point defects, vacancy defects, self-interstitial defect in elemental solids, Schottky defects, and what are the conditions and consequences of Schottky defects. As we know, what is the defects or imperfection, and it is at absolute zero, crystal tends to have the perfectly ordered arrangement. So at absolute zero temperature, they have orderly or perfectly ordered arrangement of the particles, and this arrangement corresponds to the state of lowest energy. As the temperature increases, the crystals start deriving from the perfectly ordered arrangement, and any deviation from the perfectly ordered arrangement of constituent is the defect or imperfection. These defects are sometimes known as thermodynamic defects because number of these defects depends on the temperature. Crystal may also have additional defect due to presence of impurities. Many properties of crystalline solid, such as electrical conductivity and mechanical strength, can be explained in terms of imperfection. Imperfection not only modify the properties of solid but also give rise to a new properties. So there are mainly two types of imperfection: electronic imperfection, atomic imperfection, and we are discussing here atomic imperfection. And in case of atomic imperfection, the defect which arise due to the irregularities in the arrangement of atoms or ion are known as atomic imperfection. And these are there are two mainly types: stoichiometric point defects and in non-stoichiometric. So different types of defects we are discussing in this part. And it is also observed that the naturally occurring crystalline substance do not have perfect crystals. They have disorder or irregularities. So this irregularity is known as the defect, and defects created during the process of crystallization, which can be minimized by carrying out the crystallization at slower rate. So crystal with no imperfection are possible only at absolute zero temperature, and above this no crystalline substance is 100% pure. So they contains defect. Now it is also observed that the crystal defects, nature of crystal defect, electrical neutrality of the solid is maintained. It is important to note that sometimes defects are created by intentionally as per the requirement, as per the desired properties of the substance. And mainly there are three types of defects. One is a point defect, second is a line defects, and third is a plane defects. So what is point defect? We can say that different types of point defects are there, and we can say in case of point defects, so far we have discussed and we know point defect where there are no foreign atoms. Foreign atoms can occupy interstitial or substitutional site in the crystal. Solid solution of group 13 to 15 impurities with group 14 element such as silicon or germanium are great interest in the electronic industry. And in this case of the point defects, and these point defects are of different types. So these are, now we are discussing here about the different types of defects. So here first one is the point defects. So these defects shows irregularities in the arrangement of at the lattice point of the crystalline solid. Actually there are three major classes of the point defects, and these three major types of point defects are stoichiometric point defect, impurity defect, and non-stoichiometric point defects. So in case of point defects, one of the particle is replaced and occupy, creating the vacancy. So this is the point defect, and we can say that in case of point defects, it is due to the presence of foreign atoms. So arrangement is there, but there is an introduction or the presence of foreign atoms. So these point defects are there, point defects are created. And in this case of the point defects, we can say the atomic defect caused by missing or misplaced ion are the point defects. So again repeating, as we know, the defects which arises due to the irregularity in the arrangement of atoms or ion are the atomic imperfection or defect. The atomic defects caused by missing or misplaced ion, missing or misplace of ion, are known as the point defects. So different types of point defects, mainly three types are there shown here: stoichiometric point defect, impurity, and non-stoichiometric point defects. And in case of number one, stoichiometric point defects. So what is the stoichiometric point defect? Stoichiometry means there is a equal number of ions, positive and negative ions. Stoichiometry is maintained. So stoichiometry means equal number of ions are present in the crystal. So there is a stoichiometric point defects. So chemical formula of the compound which shows the fixed ratio. So the compound which has fixed formula of ratio of number of atoms, of number of cations or anions. This ratio, fixed ratio, is known as the stoichiometric compound. So first of all we should have to know what is the stoichiometric compound. So stoichiometric compound which contain equal number of positive and negative ions, or equal number of the, or we can say fixed ratio of number of atoms. So it is not stoichiometric, fixed ratio is there. And in this case of stoichiometric compound, stoichiometric defects are there, and stoichiometry is remain unchanged. Generally it is in stoichiometric the ratio is remain unchanged. We can say that in other words, ratio of number of atoms or number of cations or anions of the compound remain the same as shown in the chemical formula of the compound. We can say that there are four different types of stoichiometric point defects. There are mainly four different types of stoichiometric point defects. One is a vacancy defect, that is the stoichiometric point defects are mainly four types. One is vacancy defect, self-interstitial defect, Schottky defects, and Frankel defects. So there are mainly four different types of stoichiometric point defects. As we have seen, point defects are due to misplace or missing the point in the arrangement. So our stoichiometric point defects are mainly four types. One is a vacancy defect, self-interstitial defect, Schottky defects, and the Frankel defects. So one by one we will discuss all these defects. So now it is clear what is point defect. One of the particle is missing or displaced, which is known as the point defect. in the irregular arrangement of the crystalline substance. Now what is the vacancy defect? So it is shown in the figure that this is the regular arrangement stoichiometric ratio. Regular arrangement of the particles are there, but now in this line, this is the missing particle. So here is a missing, here is a vacancy, here is a vacancy also. In this line, here is a missing one particle. In this case, here is a missing of particle. So there is a vacancy. So when in the regular arrangement in a stoichiometric ratio, the compound in a fixed ratio is there, but now particles are missing. So here is particle is missing, here is also particle is missing in a regular arrangement. Such type of vacancy, which is known as the vacancy defect. So we can say that during the process of crystallization of the solid, particle is missing from its regular site. So what is? During the process of crystallization of solid, particle is missing from the regular site in the crystalline substance or crystal lattice. This missing particle creates the vacancy. So particle is missing and it created the vacancy in the lattice structure. This is known as the vacancy defect. So some of the lattice site are vacant because of missing particle, which is shown in this figure, and crystal is said to have vacancy defect. So vacancy defect can also be developed when substance is heated. So this type of vacancy defect can also be created when the substance is heated. So here it is shown what is the vacancy defect, and in figure it shows clearly how the particles are missing and create the vacancy. Such type of defects are known as the vacancy defect. So particle is missing from a regular arrangement and there is a created the vacancy and forming the vacancy defect. So this is known as vacancy defect, and this defect generally occur or develop when the substance is heated. So this is one type of the stoichiometric point defect, vacancy defect. Second is self-interstitial defect in elemental solid. How it is there? So this type of defect in the crystal occur, and we can say that interstitial site in the crystals are void in between the particles at lattice point. So it is shown in this figure. When some particles of crystalline solid occupy the interstitial site in the crystal structure, such type of self-interstitial defect, it is known as the self-interstitial defect. And shown here, see now here, this is the regular arrangement of the particle, but this is the particle which occupy interstitial site in the arrangement of the lattice. So this is the particle, this is also, so in one line 4 particles are there, 4 particles, but now here this is the particle and this is the particle which occupy interstitial. So self-interstitial, and there are two ways that these self-interstitial defects are created. Now firstly we can say that extra particle which occupy an empty interstitial space in the crystal structure is shown here. So this is the extra point. Regular arrangement is there, stoichiometric arrangement is there, but now this is the extra particle. This is the extra particle which is shown in the figure, and this type of defect is known as the self-interstitial defect. So in case of there are two ways of creating this type of defect. First is particle occupying an empty interstitial space in the crystal structure, and this extra particle is same as those already present in the lattice point. So such type of defect is known as the self-interstitial defect. So it is shown clearly in the figure. तो इस फिगर में ये बताया कि ये जो अरेंजमेंट है और ये अरेंजमेंट है, स्टोइकोमेट्रिक अरेंजमेंट है, ये भी अरेंजमेंट है, लेकिन ये एक्स्ट्रा पॉइंट है, दिस इज आल्सो एक्स्ट्रा पॉइंट, ये जो एक्स्ट्रा पॉइंट है ऑफ द सेम, ये जो अरेंजमेंट पार्टिकल्स है, सेम पार्टिकल ऑक्युपाई इन इंटरस्टिशियल साइट. ये दूसरा पॉइंट जो है सिमिलर पार्टिकल दूसरे जगह यहाँ पे ऑक्युपाई हो जाता है, इसलिए ये देयर इज अ डिफेक्ट, देयर इज नो रेगुलर अरेंजमेंट, सो सम डिफेक्ट क्रिएटेड. सो इसी को बोलते हैं सेल्फ इंटरस्टिशियल डिफेक्ट. सेल्फ पार्टिकल यहाँ का जो भी पार्टिकल अरेंजमेंट में है वही पार्टिकल इसमें कोई एम्प्टी जो स्पेस है लैटिस में वहाँ पे ऑक्युपाई कर लेता है स्पेस, वो एक्स्ट्रा पॉइंट हो गया. तो ऐसे डिफेक्ट को बोलते हैं सेल्फ इंटरस्टिशियल डिफेक्ट. पार्टिकल्स आर सेम, नो एक्स्ट्रा और न्यू पार्टिकल्स आर देयर. सो दिस इज द फर्स्ट वे creating the defect in the interstitial defects. This extra particle increase the total mass of the substance without increasing the volume, and therefore density increases. Because it is the extra, therefore density increases. Extra points are there in the regular arrangement. Second way we can say that here is shown elemental solid. In case of elemental solid, a particle gets shifted from its original lattice point and occupy interstitial space in the crystal, which is also shown here. तो इसमें क्या होता है, ये सेकंड जो है, सेकंड वे, ये रेगुलर अरेंजमेंट है और इसमें ये रेगुलर अरेंजमेंट का एक पार्टिकल यहाँ से मिस हो जाता है एंड ये दूसरी जगह इंटरस्टिशियल साइड में आ जाता है. तो ये इस टाइप का, इसको बोलते हैं सेल्फ इंटरस्टिशियल डिफेक्ट. दो टाइप के हैं, फर्स्ट एंड सेकंड. फर्स्ट में क्या था कि एक्स्ट्रा पार्टिकल सिमिलर टाइप का एक्स्ट्रा पार्टिकल ऑक्यूपाई होता है इंटरस्टिशियल साइड पर. सेकंड में क्या है कि ये जो पार्टिकल है यहाँ से निकलता है, रेगुलर अरेंजमेंट में से यहाँ से निकल के दूसरी जगह वो ऑक्यूपाई करता है स्पेस इन लैटिस स्पेस. So this type of defect is known as the self-interstitial defect. So self-interstitial defect in elemental solid में दो टाइप के होते हैं, अपन ने देखा है, एक्स्ट्रा पार्टिकल एंड हियर वैकेंसी यहाँ से मिस होता है और ये वैकेंसी क्रिएट होता है और यहाँ पे वो इंटरस्टिशियल साइड पर वो ऑक्यूपाई करता है. तो देयर आर टू वेज ऑफ इंटरस्टिशियल डिफेक्ट्स. तो इस टाइप से ये self-interstitial defects है which is created by the particles in the crystal structure. In case of interstitial defect, we can say that it is also very important to note that in case of second case, because of the displacement of the particle, a vacancy defect is created at its original regular lattice site. जहाँ से वो पार्टिकल निकलता है वहाँ पे वैकेंसी होता है और दूसरी जगह वो ऑक्यूपाई कर देता है. At the same time, interstitial defect result at its new position. We can say that in this case of the defect, there is a combination of vacancy defect and the self-interstitial defect. So vacancy भी हो जाता है और interstitial defect भी है. So this defect preserve density of the substance and because there is neither loss nor gain of mass of the substance. तो यहाँ पे कोई density increase नहीं होती है. So in this case there is a defect. In this case of defect, density of the substance is preserved because there is no neither loss or gain of the mass of substance. Therefore, it preserved. And so this is an important part in this case of interstitial defects. Third type है Schottky defects. It is very important from the examination point of view. What is Schottky defects? So in short, we can say that what is meant by the Schottky is the name of scientist. Schottky is the name of scientist, and we can say that this type of defect is created when one positive ion and one negative ions are missing from their regular or respective position, leaving behind pair of holes. Schottky defects are more common in case of ionic compound with higher coordination number and where the size of positive and negative ions are almost equal. And Schottky defects are, this type of defect is created when one positive and one negative ions are missing from their respective position. So positive and negative are missing from their respective position and creating the holes. There is a hole. Schottky defects are more common in case of ionic compound like NaCl, KCl, cesium chloride, KBr. So Schottky defects are very common in case of ionic compound. And so we can say that there exist two types of hole per ion pair lost, and here is shown Schottky defects. In case of ionic solid, equal number of cations and anions are missing from the regular position in the crystal, that is, and creating the vacancies shown here. So there is a missing of positive and equal number of positive and negative ion. तो ये इसमें देखो यहाँ पे ये नेगेटिव आयन है, एनायन वैकेंसी हो गई. यहाँ पे देखो पॉजिटिव वैकेंसी है, तो ये नेगेटिव और ये पॉजिटिव वैकेंसी, एनायन वैकेंसी, कैटायन वैकेंसी, बोथ आर मिसिंग इक्वल. तो ये यहाँ से नेगेटिव और एक पॉजिटिव इक्वल में आयन पेयर अगर मिस होती है उसको बोलते हैं Schottky defect. दिस इज गिवन बाय Schottky. Schottky is the name of scientist. This scientist have suggested when equal number of positive and negative ions are missing from the lattice site, this is known as the defect and which is known as Schottky defects. उसको बोला है Schottky defects. So equal number of cations and anions are missing from the regular position in the crystal lattice, and creating the vacancy is shown in this figure. And it shows that vacancy created by the loss of cation is always accompanied by the vacancy formed by loss of anion. So equal number of cation anions are missing and creating the vacancy. So there is an anion vacancy and also cation vacancy. So this is known as Schottky defects. In this defect there are two holes per ion pair, and one created by missing cation and one hole is other hole is created by missing anion. Such type of paired cation anion vacancy defect is known as Schottky defects. So there is a missing of cation anion pair vacancy, defect is created which is known as Schottky defects. Now there are some conditions for the formation of Schottky defects. First condition is Schottky defect is found in ionic compound with the following characteristics, and they should have high degree of ionic character, high coordination number of anion, small differences between size of cation and anion, and the ratio of cation and anion is not for below unity. So this is the first condition for the formation of Schottky defects. And second, there are also some consequences of Schottky defects. As the number of ion, what are the consequences of Schottky defects? So number of ion decreases. As the number of ion decreases, mass also decreases. However, we can say that volume remain unchanged. Therefore, we can say that the density of the substance decreases. So as the number of ion decreases, mass also decreases, and therefore we can say that volume remain unchanged. Therefore, hence the density of the substance decreases. Second point is that number of missing cation and anion is equal. Therefore, electrical neutrality of the compound is preserved or maintained. So in case of Schottky defects, equal number of cation and anions are missing, and therefore electrical neutrality is maintained, or electrical neutrality of the compound is preserved. Third point is that this defect is found in case of the ionic compound crystal like sodium chloride, silver bromide, potassium chloride, and also in case of the potassium bromide, cesium chloride are the compounds. And these are the ionic compound where generally it is common in case of ionic compound. So Schottky defects are common in case of the ionic compounds. So in today's part we have seen what are the different types of defect, what is the point defects, and what are the different types of point defect. Three different types: point, line, and also plane defects are there. And again now stoichiometric defects are 4 types, and all these defects in the crystalline substances we have seen with the examples, and some remaining defects, non-stoichiometric defects, we will discuss in the next part. So today we stop here, and this is very important that Schottky and Frenkel defects are important. Schottky defect, we have seen there is a missing of cations and anions and creating the vacancy, which is known as Schottky defects. And Frenkel is also name of scientist. He has also given the defects. So the Frenkel defects and non-stoichiometric defects we will discuss in the next part.